Hello ladies and gentlemen, we are the representatives of Sekolah Fatimah Malaysia for the Iysie 2021 competition. Hence, my team Afrina Farzana, Iman Nadira, Amni Iman and Ani Zafira are proud to present to you Contelaeis.
Contelaeis is derived from French word conte, which means container, and Iysie come from the scientific name of palm oil tree. Our product is made up of dry palm oil leaves, tapioca starch and sodium hydroxide.
We also imagined that Contelaeis could be a waste converter to millions of money. Even so, before things get exciting, let's first take a look at our inspiration. When we search up the statistics of plastic waste produced each year, packaging, mainly of course food plastic packaging, contributes the most waste with 141 million tons roughly each year. Moreover, we decided to profit palm oil trees, which is the plant which has the highest population in our country, Malaysia. We are thinking to maximize the usage of the tree rather than only extracting the oil. We decided to use the fallen dry leaves which are mostly being burned or thrown. This is what we meant by turning waste to money.
In addition, do you know 1 million marine animals are killed each year due to the plastic debris in the ocean? Plastic and polystyrene suffocate marine life. Fish, seabirds, sea turtles, and marine mammals can become entangled in or ingest plastic debris, causing suffocation, starvation, and drowning.
Secondly, non-biodegradable material used in food packaging. Plastic packaging is extremely wasteful and impacts Earth ecosystems on which we depend. 9.2 billion tons of plastic have been produced, of which only 9% has been recycled properly. Therefore, taking all of the aspects in concern, we hope to reduce plastic waste specifically produced from packaging for a better world.
What are our objectives? First of all, our products seek to attain energy independence and promote efficient utilization, which we aim to no longer dependent on non-renewable sources like fossil fuels by using only organic sources. Next, we aim to conserve and minimize the impact on the environment so that there will be no more water pollution or any logging operations that provide paper products. As a result, our product could protect our biodiversity and ecosystem. Finally, our product aims to improve the quality of life for all. By using Contelaeis, there will be no more smell pollution or toxic pollutants from burning plastic, which can affect serious health problems such as cancer.
Now, let's do some experiment.
For the first experiment, we are going to determine the production of the material. First of all, we are going to prepare our material used, which is dried leaf. For this time being, I am using dried palm oil leaves as my type of material. The second step is we need to rinse the dried palm oil leaves with water. Next, we need to put the material inside the pot and boil it. Then, we add 20 grams of sodium hydroxide into the mixture. Here we could see some reaction occurred during our experiment. After that, we have to rinse the previous boiled leaves with cold water to neutralize the pH value of the material.
The fifth step for sample A, half of the boiled leaves are blended. And the sixth step for sample A, the paste are put on a mold. Moreover, for sample A, the fibers are left under the sun exposure until it dries. Lastly, for sample B, the blended excess paste is heated together with water and tapioca starch is added. Last step, for sample B, step 6 and step 7 is repeated.
And here is the result of our experiment after the sample being dried. Both samples took almost 2 days to dry out. We could see a very huge difference between these two samples. The sample A that did not contain any tapioca starch is grinded and cannot be used as our base of product, while sample B that contained tapioca starch is rigid and meets the criteria to be the base of our product.
The second experiment is the durability experiment. To do this experiment, we clip on plastic bags onto the samples and we add on coins gradually until the samples torn off. As a result, sample B can load 34 coins in total while sample A can only load 28 coins before both of the samples become torn.
From the data obtained, we could see that sample B, which has tapioca starch in it, has a better strength compared to sample A.
Therefore, sample B is the most suitable material for our product. Next, the decomposition experiment. To start off, we plant sample B of Contelaeis, which contains tapioca starch, in a container that is filled with soil. Same goes to the plastic sample. Both of the sample are observed for a week. As for the results, let's start with the Contelaeis sample. As you can see, there are obvious changes from day 1 to day 7. We observed that Contelaeis started to decompose on the second day, which we've tabulated the data in a table. For the plastic sample, the plastic remains in the same condition from day 1 to day 7, which means decomposition doesn't occur. And thus, here in the table, we can obviously see that Contelaeis has a higher rate of decomposition as it only took a week to decompose completely. Contelaeis is derived from palm oil leaves, which makes our product 100% organic and biodegradable. Dry palm leaves have dead plant cells, meaning the cells are completely dry. Therefore, it can shorten the time taken for our product to dry. On the other hand, fresh palm oil leaves have living plant cells, which of course contains high water content, which can delay the time of our product to dry. Moreover, moisture of the leaves allow microorganisms to grow on our product, resulting in a moldy product, which is not what we wanted. Now that I've made myself clear, next, let's break down the significance of our procedures. Firstly, we carried out fiber treatment to remove coating of hemicellulose and lignin to only obtain the cellulose of palm oil leaves. To do so, that's why we boil the leaves in lye and grind them in the blender. It is to reduce the content of non-cellulosic binding materials. Now that cellulose fibers are obtained, hydrogen bond can now be formed between the molecules in cellulose of palm oil leaves. The hydrogen bond provides mechanical strength and chemical stability, which is the perfect property needed for packaging. Hydrogen bond also lifts the melting and boiling points of our product since more heat is needed to overcome the forces of attraction between cellulose molecules and the rate of insolubility in water will increase. Next, sodium hydroxide used in the production of Contelaeis also functions in reducing the hydrophilic property of fiber by reacting with hydroxyl groups in cellulose. It can also improve the mechanical property of Contelaeis by increasing the content of cellulose in fiber. Why is tapioca starch chosen as the best binder for our product? Tapioca starch is known for its high viscosity property, which could provide Contelaeis a firm texture to act as a durable container. Tapioca starch also helps increasing the strength and smoothness of material, making our product to look nicer in the market. Tapioca starch also has a high melting point. This way, our product won't be melted easily due to the hot food or weather. Sticky container problems can be avoided. As tapioca starch is used in the production, then gelatinization will occur when starch is heated in presence of water. When treated with hot water, tapioca starch turns into a thick paste. This is because the granules in tapioca starch lose their orderliness and swell from large amount of water moving in and becomes trapped inside the swollen granules, causing the liquids to thicken. As a result, strong bond is formed between the fiber and tapioca starch, which provides a higher mechanical strength for our product.
In conclusion, our product is definitely biodegradable because it is capable of being decomposed by bacteria. Our product is also eco-friendly as it prevents contribution to air, water and land pollution. Moreover, Contelaeis has a high durability since it is strong. Hence, our product can last longer without breaking or become less in quality. Lastly, Contelaeis is a low-cost product.
As we can see, the cost of our product is only 6 cents each, which is very cheap and good for commercial purposes.
So, here is one of our trial to make a prototype. We can see that Contelaeis doesn't lose its shape and is compatible as a container material.
We hope that our product can help to increase the income of farmers as they can sell waste from their agricultural activity, provide a better environment because less greenhouse gases will be emitted as forest destruction is reduced. Our product also can reduce pollution as it is biodegradable, and last but not least, we really hope that our product will have a huge impact on young developers to make it as their inspiration to continue inventing for a better world.
As for our future improvisation, we hope that Contelaeis will come out in various shapes and use such as cups and paper bags, not only as container. Moreover, we hope that we can add a substance that is able to decolorize Contelaeis so that it will be more presentable and convincing to be used. Lastly, we would like to incorporate nanogrind technology. Nanogrind technology is the process of making small particles even more compact to produce a new product. With the help of nanogrind technology, Contelaeis will be available in multiple industries with a lower cost to help change the world.